The runtime of a blockchain is the business logic that defines its behavior. In substrate-based chains, the runtime is referred to as the state transition function. It is where substrate developers define the storage items that are used to represent the blockchain state as well as the functions that allow blockchain users to make changes to this state. In order to provide its defining forkless runtime upgrade capabilities, Substrate uses runtimes that are built as WebAssembly bytecode. Substrate also defines the core primitives that the runtime must implement. The core Substrate codebase ships with Frame, parity system for Substrate runtime development that is used for chains like Kusama and Polkadot. Frame defines additional runtime primitives and provides a framework that makes it easy to construct a runtime by composing modules, called palettes. Each palette encapsulates domain-specific logic that is expressed as a set of storage items, events, errors, and dispatchable functions. Frame developers can create their own palettes and reuse existing palettes, including over 50 that ship with Substrate. The Assets module provides functionality for asset management of fungible asset classes with a fixed supply. The Aura module extends Aura consensus by managing offline reporting. For the most part, this section is focused on Substrate runtime development with Frame. Keep in mind that Frame is not the only system for Substrate runtime development. The Substrate runtime is composed with a set of primitive types that are expected by the rest of the Substrate framework. Core primitives. The Substrate framework makes minimal assumptions about what your runtime must provide to the other layers of Substrate. They are mandatory to define and must fulfill a particular interface in order to work within the Substrate framework. There are an additional set of primitives that are assumed about a runtime built with the Substrate frame. The Substrate runtime API is the crucial interface between the node and the runtime. Every call that goes into the runtime is done with a runtime API. The runtime APIs are not fixed. Every Substrate user can define its own APIs with decal runtime APIs and implement them in the runtime with impl runtime APIs. The framework for runtime aggregation of modularized entities is a set of modules and support libraries that simplify runtime development. Palettes are individual modules within Frame that host domain-specific logic. Frame provides some helper modules to interact with Substrate primitives, which provide the interface to the core client. When building with Frame, the Substrate runtime is composed of several smaller components called palettes. A palette contains a set of types, storage items, and functions that define a set of features and functionality for a runtime. The system library provides low-level types, storage, and functions for your blockchain. All other palettes depend on the system library as the basis of your Substrate runtime. The system library defines all the core types for the Substrate runtime, such as origin, block number, account ID, hash, header, version, etc. It also has a number of system-critical storage items, such as Executive Module. The Frame Executive Module acts as the orchestration layer for the runtime. It dispatches incoming extrinsic calls to the respective palettes in the runtime. The executive module is not a typical palette providing functionality around a specific feature. It is a cross-cutting framework component for the frame. It works in conjunction with the frame system module to perform these cross-cutting functions. The executive module provides functions to check transaction validity, initialize a block, apply extrinsics, execute a block, finalize a block, start an off-chain worker. The executive module is not a typical palette providing functionality around a specific feature. It is a cross-cutting framework component for the frame. It works in conjunction with the frame system module to perform these cross-cutting functions. The executive module provides functions to check transaction validity, initialize a block, apply extrinsics, execute a block, finalize a block, start an off-chain worker. The runtime library brings together all these components and palettes. It defines which palettes are included with your runtime and configures them to work together to compose your final runtime. When calls are made to your runtime, it uses the executive palette to dispatch those calls to the individual palettes. Some palettes will be sufficiently general purpose to be reused in many blockchains. Anyone is free to write and share useful palettes. There is a collection of popular palettes provided with Substrate. Let's explore them. Collective system. Members of a set of account IDs can make their collective feelings known through dispatched calls from one of two specialized origins. The membership can be provided in one of two ways, either directly, using the root dispatchable function setMembers, or indirectly, through implementing the change members. The palette assumes that the amount of members stays at or below max members for its weight calculations, but enforces this neither in setMembers nor in change members sorted. A prime member may be set to help determine the default vote behavior based on chain config. If prime default vote is used, the prime vote acts as the default vote in case of any abstentions after the voting period. If more than majority then prime default vote is used, then abstentions will first follow the majority of the collective voting, and then the prime member. Voting happens through motions comprising a proposal plus a number of approvals required for it to pass and be called. Motions are open for members to vote on for a minimum period given by motion duration. As soon as the needed number of approvals is given, the motion is closed and executed. If the number of approvals is not reached during the voting period, then close may be called by any account in order to force the end the motion explicitly. If a prime member is defined, then their vote is used in place of any abstentions and the proposal is executed if there are enough approvals counting the new votes. If there are not, or if no prime is set, then the motion is dropped without being executed. The contract module provides functionality for the runtime to deploy and execute WebAssembly smart contracts. This module extends accounts based on the currency trait to have smart contract functionality. It can be used with other modules that implement accounts based on currency. These smart contract accounts have the ability to instantiate smart contracts and make calls to other contract and non-contract accounts. The smart contract code is stored once in a code cache and later retrievable via its code hash. This means that multiple smart contracts can be instantiated from the same code cache without replicating the code each time. When a smart contract is called, its associated code is retrieved via the code hash and gets executed. This call can alter the storage entries of the smart contract account, instantiate new smart contracts, or call other smart contracts. Finally, when an account is reaped, its associated code and storage of the smart contract account will also be deleted. The smart contract code is stored once in a code cache and later retrievable via its code hash. This means that multiple smart contracts can be instantiated from the same code cache without replicating the code each time. Senders must specify a gas limit with every call, as all instructions invoked by the smart contract require gas. Unused gas is refunded after the call, regardless of the execution outcome. If the gas limit is reached, then all calls and state changes are only reverted at the current call's contract level. For example, if contract calls B and B runs out of gas mid-call, then all of B's calls are reverted. Assuming correct error handling by contract A, A's other calls and state changes still persist. The democracy palette provides a democratic system that handles administration of general stakeholder voting. Democracy palette. The democracy palette handles the administration of general stakeholder voting. There are two different queues that a proposal can be added to before it becomes a referendum. 1. The proposal queue consisting of all public proposals, and 2. The external queue consisting of a single proposal that originates from one of the external origins. Every launch period, a length defined in the runtime, the democracy palette launches a referendum from a proposal that it takes from either the proposal queue or the external queue in turn. Any token holder in the system can vote on referenda. The voting system uses time lock voting by allowing the token holder to set their conviction behind a vote. The conviction will dictate the length of time the tokens will be locked, as well as the multiplier that scales the vote power. Skeleton of a palette. The palette supports the use of any Rust library which compiles with the no-std flag. Use support. 2. Runtime configuration trait. All of the runtime types and consts go in here. If the palette is dependent on specific other palettes, then their configuration traits should be added to the inherited traits list. Pub trait config, system, config. 3. Runtime events. Events are a simple means of reporting specific conditions and circumstances that have happened that users, dApps Entertain explorers would find interesting and otherwise difficult to detect. Decal event. 4. Runtime storage. This allows for type-safe usage of the Substrate storage database, so you can keep things around between blocks. Decal storage. 5. The palette declaration. This defines a module struct that is ultimately exported from this palette. It defines the callable functions that this palette exposes and orchestrates. Actions this palette takes throughout block execution. Decal module.